Hello viewers. So welcome to this another video on networking. So we have seen this or like we are continuing our series for DNS protocol. So we have created two videos. In the first video we covered the introduction section where we had an overview of how it works and why we need the DNS protocol. In the last video we have seen the DNS packet formats, and in today's video we are going to see the simulation in CPT. So if you have not seen the previous videos, you might have a link popping up over here on the top right in the I button. Please go through and watch those videos, and yeah, without wasting much time, let's get started with today's video. So we'll start our CPT demo. So we have this basic scenario setup. We'll explore more scenarios, but we'll start with the simplest one. So where here we have just one network, and all our devices, end devices, and our DNS server will be in the same network. So I can just make a note. So we can assume this network is 192.168.10.0/24. So we have this network over here, and we can give this machines an IP 192.168.10.1 and 192.168.10. Let's say 3, and here we can start with 2. We will use later on. We'll also introduce default gateway, so that's why I'm leaving 10.1 over here for the default gateway IP addressing. And the server 192.168.10.100. So the DNS will be here, so we can just write DNS. So DNS server IP will be 10.100. Now we don't have a DHCP server over here to dynamically assign this devices an IP address. So we will in this video we'll statically configure all the IP addressing and DNS server also. So we can leave these fields empty, but we will put the DNS over here 192.168.10.100, and in the fast Ethernets the IP address should be 10.2. Yeah, that's it. For the PC0 we have configured the settings. For laptop, we'll again configure default gateway statically 10.100, and the fast Ethernet should be 192.168.10.3. yeah, that should be it. So we have configured these two end devices. Now we will configure the DNS server. Now every time when the DNS works, we need some hosted site where you can have the mapping for that site, domain name of that site with the IP address. So this server we need to enable two services, DNS and HTTP, which means there must be some HTTP site where we will be visiting. That we'll see how to configure, but before that we will configure the server settings. So DNS server we will keep this empty for fast Ethernet 0/ the 0 interface, fast Ethernet 0 interface. We will assign the IP address 10.100, and this is the subnet mask. I forgot to show you what it will be without the DNS server. So ignoring the DNS configuration, we can right now turn off the DNS service, and we can see the HTTP services are running. And you can see now if we go to any of the devices that are there in the same network, so we can go under the web browser. So it will take some so now if I type here the IP address of this server, where actually right now HTTP services are running but DNS services are not running, so we can type 192.168.10.100, and you can see we can see this page, Cisco Packet Tracer. So this is nothing but the index.html we can edit. So yeah, this is this page, web page, that is served from this server. Now what we can do is we can turn on the DNS, and we can see we have the mapping. So if someone types handle.com, the A record for that is like 192.168.10.100. Now which is the IP address for this server only. So now you can see that we have mapped this particular IP address with this domain name. Before that we can turn off, and we can see if we just go into web browser, and if we just want to write hanil.com, it should say hostname does not resolve. It should say that. We can fast forward. Yeah, you can see it says the hostname unresolved. Now if we go over here also, if we go and type hanil.com, it will take some time. It will try to query the DNS server, and DNS server actually it will time out. So after some time you should be seeing host name not resolved. We can wait for some time. And you can see it says hostname unresolved. So now right now we don't have DNS server running, but what we can do is we can go over here and just turn on the DNS, and we can see that we have the domain name hanil.com that is mapped with the IP address of the HTTP server, which is 192.168.10.100. Or what we can do is we can have another web server. So with this we can connect another server, and here it is. And now under the configuration section we can give the fast Ethernet IP address 192.168.10.200, and that is the subnet mask. Here we can see the HTTP service is already running. So under the index.html we can edit this file, and instead of Cisco Packet Tracer we can write hanil packet tracer, and we can save this. Yes, we want to save this file manager. So now you can see we can configure the DNS server in such a way. Here. So under the DNS we can configure, if someone wants to connect to hanil.com, we can point those out to 200. Yeah, and if someone wants to connect to cisco.com, then they can go to 192.168.10.100, which is the IP address for this server only. We can add that record. So we have two domain name mapping. So one for cisco.com, for which the web server is hosted over here, which is server 1, which is the cisco.com, which is the web server hosted on the same server where the HTTP service is running, and the IP address for that is 192.168.10.100, which is the IP address for this particular server. You can see we have configured over here, and we have another record which is called hanil.com. So that is the domain name, and for which we have IP address 192.168.10.200, which means the web server for the, is it is hosted over here on this server. Now we can go through any of the end device, and under the web server we can write cisco.cisco.com. You can see we receive this package which is Cisco Packet Tracer. Now we can go and type hanil.com, and you can see now we see Hanil Packet Tracer. And if you want, you can go through, we can just go to simulation, and we can try to go to web server, and we can write hanil.com, go, and now we can trace the packet. So you can see DNS client sends an DNS query. So this is a DNS query packet, and you can observe all the DNS packets over here, all the DNS packet fields over here. So this is an UDP packet, this is DNS header, this is DNS query, and so you can see QD count is 1, which means there is only one query, and here is the DNS query, and the name for the query is handle.com. So you can see this is how the DNS packet is sent, and the destination is 10.100, which is the DNS IP address configured on this machine. Now let's see what happens. So the switch receives the packet, and it tries to find out the MAC address for the we can see the packet actually. Yeah, so you can see the frame source MAC address was found in the MAC address. So like where we want to send the packet, that is found. So it's a unicast frame, and switch will look into the MAC address for the destination MAC address. The switch apparently find the port for the incoming VLAN number, and it is allowed. So these are like VLAN and spanning tree terminologies. And at the end, the switch will know that if you want to go to this particular MAC address, you should go from the fast Ethernet 0/3, which means this interface. And now it will send the frame. So the DNS server will receive the frame, and let's see how the responses are prepared. So we can see the inbound packet which was sent by this machine PC0. It has a query handle.com, and in the reply you can see you have DNS header, DNS query, and the query is handle.com. You can see the type is assigned 1, the class is assigned 1, and the answer for that query, it also has type 1, class 1, and the IP address is 10.200. Now let's see what happens. The packet will be sent to the switch, and switch will forward the packet to the respective port. And now let's see the packet. So the end device will receive the frame, and it will basically come to know that handle.com is behind 10.200 IP, and then it will prepare and packet. So now this is TCP packet sent to handle.com, and for that we have IP address is 10.200, and this is the TCP payload. Now we can just observe. Yeah, so the packet will be sent to 10.200, which is these web servers hosted over here. So this server will receive the packet. It will come to know that the packet is TCP packet, and it is for handle.com, which means it is destined to me, and it is asking for the HTTP traffic. So the respective service will receive the packet from the source port and destination port, and the service will process the packet, and it will reply it, and in reply you will be given an TCP payload consisting the index.html file or whatever that you have configured. So now the server will prepare the reply, it will send to the switch, and the switch will forward the packet to the respective port. And this is how you usually see the packet, and at last the fast Ethernet 0 sends out an frame. So that is because we might have some packets, the TCP, if you know the TCP working. So like if you receive an acknowledgement for the first step, then in subsequent call we will send more packets in the same go, and that will happen until we have not received the full packet. And once we receive the full packet, we will render in the web page the reply that we got from the server. So in this case we can go to real time. So in this case, that is this page that we receive. So yeah, I think that will cover the basic stuff that I want to convey to you. So this is how DNS works, and with this simple simulation you can observe the packet structures, how DNS is working, how the packet flows, and all those stuff. And in next videos we'll take a simulation to next steps. So we'll introduce more scenarios, like we'll introduce DHCP server from where we will get the DNS IP address, and we will have like DNS in the same network or in the different networks, and then the web servers can be in the same network, in the different network, and in all those scenarios how DNS will be working, that we will explore. So for the today's video, I think that's it. You have got the idea about how you can simulate DHCP inside Cisco Packet Tracer with this basic scenario, and now you can experiment further. So maybe probably I'll make another video next week, but till then you can explore on your own that how you can include DHCP web servers for similar same network or different network, and you can simulate and observe how the packet flows. So till then, keep learning and keep exploring. We'll meet in the next video. So yeah, bye bye.